Good morning, class, and welcome to this lesson on Electrostatics 2, charging by induction and contact. Today, we will be able to describe the differences between charging by induction and charging by contact. Very simple. Um, so, first off, let's define what charging means. And charging, is for lack of a better term, charging means an object carries a charge. An object carries a charge. I mean, that's pretty basic, I guess you would say, positive or negative. And so the most common way to charge something is just by friction. Just by friction. Okay. As you can see here, we have an ebonite rod or a plastic rod or a glass rod here. It could be any of those things. And they take this rod and they rub it against some animal fur, which has a lot of electrons, and just by that friction, the electrons transfer from the animal fur to the ebonite rod. So this ebonite rod is now negative. Okay, so it was charged through friction. Okay. Sometimes maybe on like a windy day, you notice that your clothes are very staticky, and you notice everything you touch is being shocked. That's because the wind, as the air passes by you, as the air passes by you, that's friction against the air in your body, and every time that friction happens, electrons are transferring from the air to your body, and so you're carrying a charge, and so every time you touch something, you're losing that charge. So this is charging by contact. Charging by contact, and that just literally means two things are touching. Charging by contact means two things are touching, and then there is also a transfer of electrons. There is a transfer of electrons. So in this example right here, we have this ebonite rod that's negative, and we touch a metal sphere. Why do we have a metal sphere? Because this is a conductor. Okay, so this is a conductor. The electrons are going to transfer to this. Now, so that means if this is negative and this sphere was neutral before, electrons are going to flow from the rod into the sphere. They're actually going to flow. There will be a transfer or a flow from one to the other, making this negative. Okay. Notice here. Notice protons don't transfer. Protons don't transfer. Only electrons. And because we might remember from our lessons in chemistry that protons actually make up the stuff. Protons actually make up this rod. Protons actually make up this sphere. So protons aren't going to move anywhere because protons don't flow. They make up these solids here, but electrons can flow from one to the other. So now we have a charged sphere that is fully negative. And notice there is an even distribution of all the charges on this sphere because likes repel. Likes repel. And so these electrons are going to try to get as far away from each other as possible because they don't like each other anyway. So charging by contact literally means electrons flow from one object to another. And so now this object that was neutral is now negative. This object is now negative. Okay, so charging by contact literally means electrons flow from one object to another. Okay, versus charging by induction. Induction means to induce a charge, but with induction there is no touching. No touching. It only comes close, or it is a non-contact force here. So we're going to bring the same ebonite rod over to this metal sphere. And as it gets closer, the electrons here are negative. Well, there are electrons already on. There are electrons already on this sphere. And so as you can see here, these electrons, because likes repel, these electrons are being pushed to the other side of the sphere. They're being pushed to the other side of the sphere. They're trying to get away from these electrons over here. So this becomes charged. It's like it has a positive end and it has a negative end. Okay, so this actually becomes charged a little bit because of these two ends. And if we took this rod away, if we took it away over here, they would even back out. And then if we brought it close again, it would be charged again. So and then if we connected this to the ground, Remember, these electrons over here are pushing these ones away. They're pushing these ones away. If we connected this to the ground, the electrons would flow down this ground wire into the ground, and then we would have a permanently positive, we would have a positive sphere. And notice we created this positive sphere without touching it to the actual charged object. We just kind of forced the other electrons away because because of this charged thing. And you're going to hear this term a lot: grounding, or the ground. Okay, and this term basically means the ground is a electron sink, or an infinite electron sink. So if it's an electron sink, basically it can electrons can always flow into the ground. That's why you have to be careful when working with electricity, because if you touch something that's charged, it'll flow through your body into the ground, and that's not going to feel good. Okay, so this is an example of a conductor. This past example was an example of a conductor. Let's go to an insulator. Even with an insulator, this is a plastic surface, and in a plastic surface, electrons do not flow, so they're not going to move around the object. But even if we bring a rod close to the surface, the electrons are still going to try to get as far away as possible. They're still going to try to get far away. So even if they can barely move, only just a little bit, they're going to move just a little bit to orient themselves away from this negative. And so this is like having a partial positive, and a partial negative end. And so, for example, you may have like charged a balloon and then put it up against the wall. You may have charged a balloon and put it up against the wall like this. And how is it sticking there? Because the balloon is negative, and the wall, it's all oriented in this way: positive, negative, positive, negative, positive, negative. And so this partial positive side is being attracted to this negative side, and so it's sticking like that. So we can actually charge by induction in an insulator as well, but it's not going to be as effective. So we can charge by induction in an insulator as well, but it's not going to be as effective.